Hi guys, I'm Katie and welcome to Simply Space. Today we're going to be talking about the Big Bang Theory. We're going to break this theory down into 3 parts for you. What it is, who theorized it, and what the evidence for it is. So let's get started. So first things first, what is the Big Bang Theory? Many people think that the Big Bang Theory describes the origin of the universe, but this is false. The theory actually describes how the universe evolved and expanded from a very small region, smaller than a molecule. This may be hard to understand, but under these conditions, normal physics don't apply. There's an entirely different branch of physics called quantum physics, which deals with how matter behaves under these circumstances. From this small region, the universe expanded for almost 14 billion years and is still expanding today. Although the name Big Bang makes the theory sound like it describes an explosion, the key concept of the Big Bang Theory is actually expansion. So now that we know what the Big Bang Theory is, let's talk about who came up with it. I'm sure you've all heard of the Hubble telescope. Edwin Hubble, the man that this telescope was named for, discovered that the galaxies surrounding Earth were moving away from us at speeds proportional to their distances. This discovery, known as Hubbles Law, was the major support for George Lemaitre's Big Bang Theory. Lemaitre reasoned that since the universe was expanding, it must have been smaller in the past, and that if you went back far enough into the past, the universe would be a single point. This small point expanded to create the entire universe that we know today. Lemaitre published this idea in 1931, and although it received much criticism at the time, almost all astronomers accept the Big Bang Theory today. So all of this sounds great, but why do astronomers actually believe it? There are many pieces of evidence that support the Big Bang Theory, but today in this video, we're only going to look at 2 of them: expansion and the cosmic microwave background. Think about the last time you looked up into the night sky and saw stars. The light coming from these celestial objects is not new. Its age depends on how far away the objects are from Earth. The time light takes to get to Earth is equal to the distance the object is from Earth divided by the speed of light. Since the objects you see in the night sky are so far away from Earth, millions or billions of light years away, the light is actually millions of years old. Therefore, the night sky gives us the ability to look back in time and see what the universe looked like millions of years ago. Over time, we have seen that the universe has evolved and changed, disproving the steady state theory. How do we know that the galaxies have changed, though? To answer this question, we look to Edwin Hubble's research. As we said before, Hubble discovered the expansion of the universe due to the Doppler Effect. Think about the sound of a police siren driving by. When it passes you and continues moving away, the sound of the pitch drops. The same thing happens to light waves. When the light radiation emitted from objects in space moves away from Earth, that radiation is stretched, causing the wavelengths of light to become longer. In the visible light spectrum, the color red has the longest wavelength. Thus, when objects move away from us, they appear to be slightly red. This phenomenon allows us to know that the galaxies are moving away from us, and this is how Lemaitre reasoned that the objects must have started at a single point. Our final piece of evidence that we will discuss today is the cosmic microwave background, CMB for short. The CMB is the leftovers of the Big Bang. At the time of the Big Bang, the universe was extremely hot. All matter existed as energetic and dense plasma. However, approximately 380,000 years after the Big Bang, this plasma fog lifted, and the universe became transparent. However, when we look to the very distant edges of the universe, we can still see the CMB. It acts as a shell, making anything outside of it undetectable. It is because of the CMB that we don't know anything about what happened before the Big Bang, and why many questions about the universe have been left unanswered. Thanks so much for watching our video on the Big Bang Theory. If you want any more information about any of the topics that we discussed today, please visit our website, link in the description below. If you like this video, please like and subscribe to Simply Space, and we will see you next time with a new space topic to simplify.